Okay, hi everyone. My name's Michael Smolenski. I'm founder of Lightstreams. So Lightstreams is a blockchain network that's been optimized for content sharing. So it's a public network, but it has a privacy element to it. So this is the stack of Lightstreams. So essentially, it's an enhanced version of IPFS. It is integrated to Ethereum, our own version of Ethereum that uses Tendermint for consensus. The way that Lightstreams came to be was actually out of my own frustration as a dApp developer, wanting to build some apps where I wanted to have privacy within a small group of participants. So you could imagine like having a WhatsApp kind of dApp, where you form a group of your friends and you want to share some content amongst your friends and just keep that content private within that group. So basically what I want to talk to you today about is the Smart Vault, which is a layer, one of the layers in our stack. So the Smart Vault is about keeping personal data private within an app, and actually keeping the application activity private as well. So separating that actually from the application itself. And also being Ethereum and tokenizing, keeping digital assets private as well. So what's unique about Lightstreams? What makes it different? Well, it's essentially about the integration that we've made between IPFS and Ethereum, and having a group of nodes keep the data private by using a smart contract to manage those permissions. So here you can see in this diagram, there's actually four nodes in this group, and Alice can share information to Bob and the other nodes in this group and keep that information private within that group, controlled by a smart contract. So what is really unique about our design? So the way that it works is that you cannot access the data unless you've been given permission. So in the smart contract, there's an access control list. If Bob in this diagram has not been granted permission, and if he requests some data from Alice's node, he won't be able to get access to it. So basically our mantra is no permission, no data. So this is a little bit different from how other permission-based systems are designed, where they focus on only encryption. So you can access the encrypted data, and then it's all about sharing the keys. Well, we go another step further, and you cannot even access the data. So in this scenario, Bob doesn't even know where the data is. So Alice's machine will actually just ignore his request. So he has no idea whether the data actually exists or not. So just to make it more clear, now Alice has actually granted Bob access to the data on her node. So you can see there on the green smart contract, you see Bob has been granted access, and now he can request the data, and obviously he can pull that file to his machine. Now the great thing about smart contracts though is you can add all the goodness of running a smart contract. So not only can Alice manually grant Bob access, but you can have cryptocurrency payments in there, so automatically there can be business rules where if Bob does so many steps, he automatically gets the file, such as purchasing this music file from Alice. And just to kind of cement the distributed nature of this, now Alice can grant permission to Claire to access the file. And now both Bob and Alice are sharing the content to Claire. And now this is kind of a private group, just like making that clear. It's not like a public group. Only those participants can access that file. Now the great part about being distributed, Alice could actually take her computer offline for whatever reason, and Bob and other people that have been permissioned to access that file will keep sharing it to Alice and other people that have been permissioned. So what are the benefits of this architecture with Lightstreams? Well, it's about data ownership. It's about self-sovereignty of data. Also, fine-grained access control through smart contracts. You can actually share the data across apps. So you can imagine actually an app that we're building called Fanbase, all that user activity could actually go into a completely different clone of the application. So we could have another company say, hey, we think we're going to build a better version of Fanbase. That's totally fine with us. And that data will ship across. So it's not in a silo as you would have with Facebook, etc. So essentially, it's a user-controlled space for application data. One point that I'd like to make, actually, that I forgot in the beginning, is the Smart Vault is actually blockchain agnostic. So we've made it to work with our version of Ethereum, which uses Tendermint for fast confirmation times with smart contracts. But we've actually designed it that it integrates with the mainnet of Ethereum as well. So if you're an application developer that's already got your app on Ethereum, no problem. You can just connect to Smart Vault today. And actually, that's what I was going to say on this slide here. So the benefit for application creators is the last point there, that's completely compatible with any Ethereum-based blockchain. There's obviously reduced storage costs. So this was another way that I got frustrated with the beginning of when I was working with Ethereum, is where do we store all this data? Obviously, if you're storing your data on a off-chain distributed data store, then it reduces your costs. And the big thing today, too, with GDPR is it reduces the data liability for the application creator because they're not holding the user's data. And that's it. So if you'd like to learn more, go to lightstreams.network. There's the docs. Lightstreams is up and live today, so you can use it. Happy to take any questions afterwards. Just come meet me. And I've also got my colleague Andrew here today, too, who's happy to speak to you as well. Thank you.